Welcome back to the Punny Math Teacher. We are going over parallel and perpendicular to all three forms of linear equations. There's our comprehension questions and our recording. So parallel perpendicular lines, based on how fast the other past videos have gone, I think I can get this all in one video. So hopefully two pages will be in one video. If not, it'll be two. So yay! And if you are here watching for perpendicular, you're going to want to jump to the middle of the video because parallel will be first. So just an FYI, I don't need to change anything on that. I just need to go to page 34. So parallel lines are at the beginning, and I don't think this will fit on one page. It might fit on one page for you. I purposely have it set up so I have 2 pages to do it in. But FYI, we're going to have 2 examples for graphs and then an example with an equation at the bottom. So if you write small, you probably could get this on one page. Just an FYI. So we are going to graph 2 lines on the same graph. So if you want to pause this and graph these 2 on your own and then come back. All right, so for this one, and go up 2 over 1. There we go. Go up 1, go up 2 over 1. Okay, and this is where you realize that you're human and you don't have graph paper. So imagine you did this perfectly. What would these look like? Parallel, because it says parallel. So definition of parallel is they don't intersect because they're always the same distance away from each other. If I measured this distance, it'd be the same as this distance, and it should be the same as that distance because I should have graphed these better. So knowing that, what was the pattern that forced these 2 equations to be parallel and to be the same distance away from each other? That pattern is because they both have the same slope. Same slope. Same slope. So I want you to make your own on the right-hand side. They should be parallel because you know they're the same slope. If you're not creative, then pick a number, any number, make that your slope. We'll do 2 and pick any number, make sure that's your same number, and then go like, I don't know. There we go. And put your same slope in that spot. Okay, I'm going to do -1/2. Because why not? And let's see if I can graph this better. Okay. Okay. I go up 2 and go down 1, 1, 2. Yep. And then go down 4, go down 1, 1, 2. I'm still off a little. That's better. So it does depend on how you go through a line, go through a point. Because I went through the same point, but it might be better if you do more points. That way you know it's more accurate. But they should be parallel because they are the same slope. Yay! And if you have graph paper, which you will have on a test, then you'll be fine. So the extension. So extension is, or example, is to write slope-intercept form of a line parallel these 2 bars, which it's 2 buttons above your shift key, shift bar, that'll make that bar symbol, parallel to 2x plus y equals 5 that passes through 0, 4. Okay. Now, there are a lot of steps to this type of question. I specifically picked one that is extremely difficult and challenging because I wanted to make sure you have an example like that in your notes, okay? So this is written in slope-intercept form, standard form, or point slope. It's written in standard form. So I don't already know the slope because this form does not give me slope. But I can take the 2x plus y equal 5, and if I rearrange it, now what form is it in? Slope-intercept. So what's the slope? Okay, so I found slope of original line. Now, after I found the slope of the original line, I need to make my new line have a slope that is parallel to this original slope. But we know all parallel lines have the same slope. So that means my new line slope equals also -2. And it tells me to pass through a point. So my B will be 4. So they gave me a nice convenient point, which is nice. So if I know a slope and a y-intercept, I can then write my slope-intercept form. All right? And if they gave you a different coordinate that was not a y-intercept, go back to your writing and slope-intercept form notes, and you'll be fine. Okay? But the main trick here was to rearrange the standard form to find the slope that was original, so I know to make it the same slope. All right? So yeah, we have time. We're going to move on to perpendicular lines, which are going to look similar. We're going to do 2 graphs and then an extension at the bottom. I'll do it in blue, why not? Okay, so we're going to graph 2 graphs. First one we're going to graph is 2x, okay, plus 3. It originally was minus, but okay. -1/2 x plus 4. There we go. So I'm going to go up through 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so go up 3, 2 over 1. Go down 2 over 1. Down 2 over 1. I'm putting more points to hopefully make this a more accurate line than I have in the past, as I didn't keep on my straight edge. Okay, next one, go up 4, go down 1, go over 2, go down 1, over 2, down 1. I don't have another 2, so we'll just leave it as that. Let's say it was closer to that. Okay. So, perpendicular, the definition is 2 lines that cross at a right angle. Using that little box to represent a right angle. So, what about these equations made them intersect such that they did form a right angle? Parallel lines had the same slope. Perpendicular lines, you know? Limes, versus lemons. Lines have a specific pattern of a slope. They are opposite reciprocal slopes. Opposite reciprocal slopes. Opposite meaning one's positive, one's negative, and then reciprocal as in one is 2 over 1. So 2 in the numerator, 1 in the denominator, and the other has that switched. So the denominator becomes the numerator, and the numerator becomes the denominator. All right, so I want you to make up your own for the second one. So just make whatever slope you want for the first one, and then you have to change it up for the second. I'm going to do a negative. I'll do a tricky one. So for this one, this is like -1 over 1. So the opposite reciprocal would be +1 over 1. Yay! So you can't quite see the reciprocal part in here. You just see opposite, but they both work. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Go down 1, down 1 over 1, down 1 over 1. Down 1 over 1, down 1 over 1. You know you like my song. You know you like my song. -3. Go up 1 over 1. So then noticing for the perpendicular, they should intersect at a right angle. So they do intersect. Parallel lines will never intersect because they're always the same distance away from each other. Perpendicular will intersect, but they intersect a specific way. And now for the extension example. So we are going to write the slope-intercept form of an equation perpendicular to, so upside down T is the symbol for perpendicular to, and you'll have to find a specific math keyboard to make that happen. Perpendicular to y equals -3/2 x minus 17 that passes through -2, 5. So last example, we were given standard form and had to rearrange to find slope. We don't have to do that anymore because we have the slope given to us. And last example, it went through the y-intercept, so we didn't have to do anything fancy. This one we'll have to do something fancy because that's not a y-intercept, so it's not as helpful to us. But I want to know the original slope is m equals -3/2. That means the perpendicular slope is going to be the opposite reciprocal. So instead of negative, it's going to be positive. Instead of 3 as the numerator and 2 in the denominator, the reciprocal makes it where 2 is the numerator, 3 is the denominator. So I know my slope, and they gave me a point. So I'm going to go back to my writing and slope-intercept form, which is on page 29. I was so close. Oh, what? 28. There we go. So I'm given a point and a slope. So I'm following these directions from C, all right? So I'm going to take my point. I'm going to replace the y with 5. The slope is 2/3. The x is -2. And I don't know my y-intercept. This means 5 equals -4/3 plus b. Add 4/3, so that's 6 1/3 equals b. That means if I know b and I know m, I can rewrite this as 2/3 x plus 6 1/3, or 19/3 if you want to be improper. Boom! Parallel, perpendicular, done in 12 minutes. Like 13, but it's okay. Comprehension questions. How will you keep these straight? How will you remember how to do the extension examples? Because you're going to see those. Like, you're gonna see them. Something like you're gonna see. Because it puts together all 3 of your forms. So, woohoo! And then if you've never used Desmos, oh, I spelled it wrong. Desmos. 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 Go to desmos.com. There's a blue, it used to be red, but now it's blue. It says start graphing or graphing calculator or something like that. That big blue button in the beginning, in the middle. Click it and then just type in your equation and you can check it. And then it's really fun. And you can click the circles of color and that'll turn on and off different functions and just explore it. Have fun with it. But yeah, have fun. Thanks for watching and have a great day.